Welcome to the Explainer. Today, we're going to completely demystify how Java applications transform from static, boring text into dynamic, interactive experiences. If you've ever wondered how the software you use actually knows what you want it to do, well, you're absolutely in the right place. Let's get right into it.
To really wrap our heads around event-driven programming, we need to start by deconstructing a single everyday action. Think about it. What is the actual anatomy of a button click? We do this thousands of times a day, right? Literally without a second thought. But under the hood of a Java app, that one simple click kicks off this incredibly fascinating, highly choreographed sequence of operations.
Okay, here's our roadmap for today. We're going to cover 1. The graphical user interface, 2. Organizing with layout managers, 3. Interactive GUI components, 4. The event-driven concept, and 5. The delegation-based event model. Basically, we're zooming all the way in from the macro-level interface you see on screen right down to the invisible micro-level engine running the whole show.
So, Section 1, the graphical user interface. This is essentially the physical body of our application. Now, a fundamental truth about modern software is that a GUI-oriented program absolutely has to respond to user actions to function. It doesn't just run top to bottom and turn off like a simple script, it waits. This is exactly what makes it event-driven. The interface just sits there, displaying graphics, essentially waiting for you to provide the spark that makes it go.
But hey, before a user can even interact with anything, those visual elements need to be structured on the screen. That brings us to Section 2, organizing with layout managers.
Think of a layout manager as the invisible skeleton of your app. It dictates exactly where every single component sits. And Java gives us 3 main tools to build the skeleton. First up, flow layout. It's kind of like text on a page. It neatly places components from left to right, dynamically wrapping them to the next line if you resize the window. Pretty handy, right? Then we have border layout, which divides your window into a compass, north, south, east, and west, with a center region that expands in all directions to fill the remaining space. Or if you want perfect symmetry, you'd use grid layout. That forces your components into an equal-sized grid, populating them left to right, then top to bottom.
With our structure locked in, let's look at the actual interactive pieces. Section 3, interactive GUI components. These components are essentially the sensory receptors of our software. You've got your standard ones, like a J button for clicking or a J combo box for a drop-down list. But text is a huge part of this too. A J label is used for uneditable text or even an image icon, while a J text field allows for single-line input. Fun fact, just pressing the Enter key inside a JText field actually fires an action event, and you can read that input data anytime using the getText command. If you need multi-line text, you'd use a JText area, which supports commands to set or pen text. Though you have to remember to wrap that one in a JScrollbar if you actually want scroll bars. Oh, and don't forget the top of your window. The swing menu hierarchy builds top-down. You start with the main JMenu bar, add a JMenu drop-down category to it, and finally place your clickable JMenu item inside. And remember this crucial detail, only the JMenu objects actually generate those action events.
Okay, moving right along to Section 4, the event-driven concept. Let's talk about the stimulus itself.
So, an event isn't just some abstract philosophical idea. In Java, it is a literal programmatic object. It's created the exact millisecond you press a key or click a mouse. The moment you interact with the software, a data package representing that specific occurrence is immediately forged right there in the memory.
Once that event object pops into existence, the system relies on an event handler. You can think of the event handler as the real brain of our program. It's the dedicated code that performs a specific task in response. For instance, let's say you're using your mouse. Java has specialized interfaces just for that. The mouse listener interface handles the clicks, the presses, the releases, and even detects when your cursor enters or exits a component's boundaries. Meanwhile, the mouse motion listener specifically handles moving and dragging. Now, to actually build this interactive cycle, programmers have to follow 3 precise steps. First, define and set up the GUI components. Second, create your listener objects. And third, and honestly this is the most critical part, establish the relationship between them. You have to ensure that the component generating the event is correctly wired up to the code waiting to respond. Because without step 3, well, you just have a button clicking into the void.
Which brings us to our final stop, Section 5, the delegation-based event model. This is Java's core interaction framework.
This model is the absolute heartbeat of Java interactivity. It operates as this inseparable triad, the event source, the event listener, and the event itself. Now, high-level interactions, like clicking that button we talked about or hitting enter in a text field, trigger what are known as action events. To process these, programmers use the Action Listener interface. And this interface is super specific. It features just a single abstract method called action performed. Programmers actually must override this exact method to define what the program should do when the event fires.
Think of the delegation model this way. The event source, like a JButton generating an event, is like a customer in a restaurant raising their hand. The event listener, on the other hand, is the attentive waiter, just standing by, waiting specifically for that signal to rush over and respond. So how do we link the customer to the waiter? Through registration. Using a command like source.addActionListener officially connects them. The source then takes on the complete responsibility of notifying the listener the very moment an event occurs. Oh, and a quick tip for you, it's actually standard practice to make your main container, like your JFrame, implement the listener interface itself just to keep your code nice and organized.
As we wrap up, take a second to look at the screen in front of you. Try to imagine the thousands of invisible delegation models firing back and forth on your device right now, just waiting for your next move. Every pixel shift, every volume adjustment, every tiny mouse hover. It's all an event being caught by a listener in a fraction of a millisecond. So with all that incredible processing power sitting right at your fingertips, what will your next event trigger? Thanks for joining me on The Explainer.